This is geometry. It's a worksheet to guess the shape. We're going to look at number 1. We notice that for these two side measurements, we look at the slopes, and we see that the slopes are considered opposite reciprocals. Here we have negative 1/2, and the other slope is the flip of this, so it would be 2/1, and it's positive. So I see opposite reciprocal slopes. So that's going to give us perpendicular sides, which are right angles. So we know we have a right angle. Over here, we see that we have 3 sides. So I know I have a right triangle. And something we're going to learn in the future, if you notice, these have specific measurements. The smallest side would be the 4. The largest side would be the 8. And the medium side is the 4√3. 4√3 is smaller than 8 because 4 times 2 makes 8. And it would have to be the square root of 4 to make this be 8. But it's the square root of 3, so I know it's smaller than 8. There is a special pattern. We haven't gone over this a lot yet, but there's a special pattern about a right triangle that has the hypotenuse twice the size as the short leg, and the longer leg √3 times that short leg. So if the short leg is 4, 4√3 is the longer leg, and the hypotenuse is double the short leg. This is going to be a 30, 60, 90 triangle. But you for sure would know that this was a perpendicular side, so right angle, and it was a triangle, so you could at least call it a right triangle. I know that the other angles have to be 30 and 60. So 30, 60, 90, right triangle. Okay, what do we see here? So we recognize, again, that there are 3 sides. 2 of the sides are exactly the same. 2 sides are congruent. That's what we notice. So this is an isosceles triangle. We don't know anything about the slopes, so we don't know if it's a right triangle. Here we have no sides congruent. They're all different. And they're not following the pattern like we had learned earlier, where one was double the size and the other one was √3 times the short leg. We don't have that pattern either. These are decimals. So this is called a scalene triangle. All the sides are different. The only thing we know. What do we see with number 4? You can pause the video. You can think about what these values are going to give you, and then you can come back and check it out. We notice that there are 4 sides. So this is a quadrilateral. This says M, so it stands for slope. So we have 2 slopes that are the same, 2 slopes that are not the same. When slopes are the same, we have parallel sides. So if we went up 1 and over 9, that would be our possible slope. If we went down 3 and over 4, that would be our negative slope. And if we went down 9 and over 1, we could still be parallel with this other side. So these 2 sides are parallel with up 1 and over 9. This one you just might need to do it twice. Okay, so what we see is one set of parallel sides. We have a trapezoid. What do we notice here? Go ahead, pause it, think about what you notice, write something down. What do you notice? What do you notice? What does this conclude? Here we have 2 sets of parallel sides. Alright, so 2 sets of parallel sides. Here we have 2 sets of congruent sides. And over here, we have 2 diagonals that are different lengths. The diagonals are not the same length. In a rectangle, diagonals have to be congruent. So we know this is not a rectangle. We see that with the E, let's see, let me try to draw this a little bit more accurately. 0 slope, -10 type slope, 0 slope. If this was the A and the B, C, and D, E is supposed to be this point that's the intersection of the diagonals. So AE is 6, and EC is 6, and 4.5 and 4.5. So the diagonals are supposed to bisect each other, which is true about a parallelogram. They're not the same length. So all I see are diagonals are not congruent. But they bisect each other. Parallelogram. All right, let's look at a couple more of these. All right, pause the video. Think about what you see with number 6. Come back. Try to give your explanation. See how we do. So we see 4 congruent sides. I see 2 sides congruent, 2 sides congruent. So 2 sets of parallel sides. But what I don't see these are perpendicular to each other. They're not opposite reciprocals. But the diagonals are opposite reciprocals. So I have 2 slopes that are down 1 and over 2. I have 2 slopes that are supposed to be, all right, that's kind of hard to draw, up 3 and over 4, up 3 and over 4, up 3 and over 4, down 1 and over 2, something like that. And our diagonals are perpendicular to each other. We're at an up and over and a down and... So we see opposite. Try that again. Reciprocal slopes, which are perpendicular diagonals. That makes this a rhombus. Let's do one more. Last one. That will do. So what I see here, I see 2 sets of parallel sides. 2 sets of parallel sides. I also see opposite reciprocals. 1/3, and you flip that upside down, we get 3 over 1. This is a positive and that is a negative. Perpendicular sides. The diagonals oh, that's interesting. So let's take a look. If we have a square which has perpendicular sides, the diagonals are going to be perpendicular to each other also. But these diagonals are not perpendicular. If we had a rectangle, the sides are perpendicular. But notice that the diagonals would not be perpendicular. They do not form a right angle. Only equal sides makes that happen. So I see the diagonals are not perpendicular. So this is a rectangle. I was suspecting that this was going to be a square, but we noticed that the diagonals were not perpendicular, so it cannot be a square.